Most of you probably already know what factorial is. N factorial is the product of all the positive integers less than or equal to n. It tells us how many ways can we arrange n number of objects. How many arrangements? For instance, there are 3 factorial ways to arrange 3 objects. 3 factorial is 3 times 2 times 1, which is 6. So with these 3 letters, you can arrange them in 6 different ways. ABC, ACB, BAC, BCA, CAB, and CBA. But there are also other variations of factorials. One example, double factorial. N double factorial is the product of all positive integers less than or equal to n, with the same parity as n. Parity means whether the number is odd or even. It means if n is odd, n double factorial is the product of all the odd positive integers less than or equal to n. Example, 5 double factorial is 5 times 3 times 1, which is 15. And if n is even, n double factorial is the product of all the even positive integers less than or equal to n. 6 double factorial is 6 times 4 times 2, which is 48. Next is primorial. The primorial of n is the product of all the prime numbers less than or equal to n. For instance, 6 primorial is the product of all the prime numbers less than or equal to 6. 2 times 3 times 5, 30. Then, we have subfactorial. Remember that factorials tell us how many arrangements of n's objects has. Subfactorials, meanwhile, tell us how many derangements n objects has, or how many ways you can arrange n objects or elements such that no element appears in its original position. Back to A, B, and C. Among the 6 arrangements, ABC and ACB isn't included since A is still in the first position. Also, BAC and CBA are not included since for the first one, C is still in the third position, and on the second one, B is still in the second position. Therefore, the derangements of the objects ABC are only BCA and CAB. 3 subfactorial is equal to 2. But there's a formula. It's this. So 3 subfactorial is equal to 3 factorial, which is 6 times 1 over 0 factorial minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorials. That's 6 times 0.3 repeating, or simply 2. Next are superfactorials. Well, superfactorial actually have 2 different definitions. The first one is defined by Sloane and named Sloane superfactorial. Superfactorial of n is the product of all the factorials from 1 to n. For example, the superfactorial of 3 is 1 factorial times 2 factorial times 3 factorial, which is 12. Superfactorial of 4 is 1 factorial times 2 factorial times 3 factorial times 4 factorial, which is 288. The other superfactorial, defined by Pickover, which is written out as this, is equal to n factorial tetrated to n factorial, which means 3 superfactorial is 3 factorial to the power of itself 3 factorial times. That's 6 to the power of 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 6. And that's already an unfathomably huge number. There is also exponential factorial, which is defined as n to the power of n minus 1 to the power of n minus 2 all the way to the power of 1. So the exponential factorial of 4 is 4 to the power of 3 to the power of 2 to the power of 1. Starting from the top, 2 to the power of 1, 2. 3 to the power of 2, 9. 4 to the power of 9, 262,144. Finally, n hyperfactorial. And hyperfactorial is the result of multiplying consecutive integers from 1 to n, each raised to its own power. Example, 3 hyperfactorial is 3 cubed times 2 squared times 1 to the power of 1. That's 27 times 4 times 1, 108.